All right, so for the second part of our lab, we're going to be plotting the HR diagram for three cluster A, B, and C. You can either plot it by hand or you can do the Colab. If you're going to plot it by hand, then you will have to plot on three of them, because you can see right here, right? I give us a sample of cluster A just to help you start it right here, but it's not incomplete. So you can have to complete this HR diagram drawing by hand. And drawing by hand is pretty simple. You do like 246A, 246A right here, right? And for example, if you have K6 and 19.3, right? So you would go to K, right? 246, right? And then 18.3 is somewhere maybe in this 15, right? 16, 17, 18.3, somewhere in this area, you make a dot. And you keep on doing that for all the the plot, and you're gonna get on the cluster A, B, and C. Now, if you do it using Colab, then you only need to do cluster B and C. This is because I already done the cluster SAMBA A for you as an example. So if you click on this link right here, it will take us to, give me 1 second. It will take us to the my Colab notebook, where you can, again, right, copy, highlight it, Control C and Control V, and bring it over. You don't need well, if you want, you can copy this instruction over too, or at least this key right here. Okay. So what I did was that I go over to this one right here. This you might have to open it like double screen, or you have dual monitor. You can do that right there, right? So it's faster. You don't have to flip it back and forth. But since I'm doing the recording, I have to flip it back and forth a little bit. I don't want to mess up with the format right here. So like, for example, here you have 19.3, 13.2, 11.4, 17.0 right here, right? And if you notice that for my apparent magnitude, right? 19.3, 13.2, 11.4, 17.0 right here. So basically, this one right here is going to be plotting on our y-axis, and the spectral classification is going to be on the x-axis. So if you look at the HR diagram, right, the magnitude, the luminosity, magnitude, brightness, you plot it on the y-axis, and the spectral class, basically it's going to tell us the temperature. It's going to be plotting on the x-axis. So you can see an example of that right here. So here is the apparent magnitude, and here is the spectral class right here. You have blue, white, yellow, red, and you can also see the temperatures of that. So for this one right here, we're just gonna look at the data in our lab, and then just enter it. One thing you want to pay attention to is that you notice that I try to do it column by column, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And I have a comma. I go to the next one like this right here. So I just go one column, like, from 19.3 to 18.3, from 19.3 to 18.3, and then I put a comma and hit enter to go to the next line, and then do the same column again like that right there. You can, just do it on one line right there, right? But if doing that right there is going to be more challenging to catch the typo. To give you an example right here, right? Now, if I, for example, forgot the last one right here, 13.3, right? And I forgot the typo. I forgot to type it in, right? And then if I run it, you know that it's going to say that it's going to give me an error. So x, y must be of the same size. So if you have 30, we see 1, 2, 3, about 34, 35, 35, I believe, data right there, right? That there has to be a matching 35 x and y. So if you, give me 1 second. Let me put it back in again. So if you have a typo like that right there, right, that's a chance that you probably mistype, mismatch, has a mismatch somewhere, right? And if you do it like this, you know, one column, one column, one column, then you can trace your error more easily. So I have the spectral class, I have the apparent magnitude. I basically just, you know, for the apparent magnitude, I basically just copy it from here. All right, this like m, right, magnitude, m stand for magnitude, into here, right? Now for the spectral class, it's a bit more tricky. You notice that it has a label like a letter K, F, K, K, G, G like this right here, right? And in Colab, you cannot plot the letters on that right there. So what we have to do is that we have to convert it to number first and do the label. And here's a conversion factor: b equal to 0, a equal to 1, f equal to 2, g equal to 3, k equal to 4, m equal to 5, right? So if you see, for example, K6, right? See K6, then you notice that K is equal to 4, right? So instead of writing K6, I write 4.6. So right there, right? Let me do another example, right? The second one is F7, right? F7. So the second one, F is equal to 2, right? So instead of writing F7, I'm writing 2.7. So you know what you got to do is you got to convert that the letter to number. For example, M1 right here, right? M1 22. M1 M will be 5, right? So you know, M1 will, so then it will convert it to be 5.1, right? So you notice that it's going to be 5.1 right here, and then 22. So when you do this right here, and then you run it, it's going to give us this this HR diagram right here. One thing you also want to notice is that for the y-axis right there, right, I have to invert it. Okay, I'm inverting it right there. The reason is because the HR diagram, you notice that it's going from lower number to higher number. Remember, right, in magnitude class in astronomy, the lower the number, the brighter it looks right there, right? So this one right here is dimmer. This one right here is brighter. So I have to invert the magnitude because in astronomy, apparent magnitude has a reverse. It's kind of reverse. So the lower the magnitude, the brighter the object looks. Okay. And another thing is that you notice that for the X text right here, right? What this line would do is that it would say, okay, you know, we had a scale 0, 1, 2, 3, 4, 5 like this right here, right? So on the label right here, right? Instead of putting 0, 1, 2, 3, 4, 5, 6, I want us to put B, A, F, G, K, M, and you know, blank like this right here. So it look nicer. It look more of an HR diagram than if you have 0, 1, 2, 3, 4 like this right here, right? And then of course the X label would be a spectral class, and the Y label would be apparent magnitude right here. And to the title, it would be cluster A. See right there, right? So this one right here, all you do is just copy and paste over to your notebook and run that. That should be you should be able to get cluster A. Okay. Now for cluster B, right? What you're gonna do is that you're gonna do the same thing. Okay, so I'm gonna delete this. I'm gonna try it again. So what you're gonna do is you're gonna do the same thing, right? But instead of saying spectral class A like this, right? You gonna change it to spectral class B. Just change the name to B like this right here. Okay. And then for, of course, for C, it's gonna be spectral class C. And then this one right here, right? You can have like something like this. By the way, the comment right here is just for it make it easier for you to understand right there, right? The Colab won't execute lines or a comment that behind the hashtag right here. It's only execute the coding like coding here. So let me go back to the cluster B, right? So for example, the spectral class is the spectral class is F1, K0, A3, B7, B4, right? And you can see that I wrote it right here already, so we don't have to copy it again. F1, K0, A3, B7, B4, A1, right? So you notice that here is F1, K0, A3, B7, B4, A1, right? So I'm just doing the first 6 point for illustration. So if you see right here is F1, then that would be 2.1. Because here's a conversion factor right here, okay? F1 is 2.1, K0 is 4.0, right? And then A3 is 1, right? So it's going to be 1.3. And then B7, B is 0, right? So it's going to have 0.7 and 0.4. And the last one is A1, right? So it's going to be A is equal to 1, right? So you can do 1.1. Okay, and this one right here, apparent magnitude, right? It just I just copy from here. The first 6 one, right? 10, 13, 8.6, 1.8, 10, 13, 8.6, 1.8, 5.0, 16. Okay, 5.16, right? So I'm only gonna do the first field just for illustration right here, right? You're gonna have to do the whole thing on the way to the end right here. So, and then what you're gonna do is, now that you have this plot right here, just copy it, Control C or Command C, highlight, Control C or Command C on your keyboard, and then go here and then create a new code cell. Okay, and now you want to plot a scatter plot, right? But you want to use the data for spectral class B. Okay, change it to B and change it to B. Okay, and then the title, of course, it's going to change it to B, right? But everything else stay the same. So when you plot it, it should give you this one right here. See right there, right? I'm only have 6 or first 6 right there, right? But if you do the rest, it should look similar to something like this right here. Not the same, right? But it's kind of similar in the ballpark right there. Okay. So when you're done this right here, go back, the same thing. Do it for cluster C. You only need to do cluster B and C. I already did A for you, right? By the way, I'm gonna delete this right to avoid the confusion right here, right? I'm going to delete this step right here. So when you look at my notebook again, you're only going to see it up to this part right here. And so when you're done with getting on of the cluster right there, right, you can answer these 3 questions right here. Arrange the cluster from the youngest to the oldest. Arrange the cluster from the closest to the farthest right here, right? So for the cluster, to arrange the cluster from the closest to the farthest, think of brightness, if of the same type. If you have star of the same type, for example, K6 or G3 or something like that right there, right? Then the one, so you're comparing apple to apple or orange to orange in this situation right here. So in that case right there, right? If you compare the star of the same type from different cluster, then the one that look brighter is gonna be closer. The one that look dimmer is gonna be further away, right? And understanding the magnitude, the apparent magnitude, would help you figure out which one is brighter and which one is dimmer, and corresponding closer and further away. Okay. The youngest to oldest right there, cluster right there, right? Also give us a hint of the cutoff point. So you look at this right here, right? There's a cutoff point. Usually the HI diagram extends from here to here, right? But if you look at cluster, you're gonna have like a cutoff point. You have no star in this area right here. So, and suddenly you have a turn off, a cutoff point right here, and it veer up like this. What this means is that these guys right here are already dead, or in the or in the process of dying right here, right? And the lower the cutoff point, for example, that means that the older the cluster is. Because let's say, right, if you have a cluster that have a cutoff point all the way over here, right? And that means that you have more younger star that have a lot shorter life expectancy that's still surviving. So if you see the cutoff point all the way up here, it means that it hasn't been around that long compared to, for example, star that had a cutoff point like over here or even over here, right? That means that a lot of those star in that cluster has died or in the process of dying right there. So it's it's going to be older. So looking at this cutoff point right here can tell you the oldest or the how old it is, how young it is. And an example, if you look at this right here, right, an example is in cluster A, this right here, right? So here is a cutoff point right here. So if you have another cluster that have a cutoff point all the way over here, right? And obviously this guy is going to be younger than this guy right here. So by looking at the cutoff point or turn-off point, then you can tell the age, how old or how young that cluster is. Then the last one is just basically classification, right? Main sequence, red giant, and white dwarf. So let me Google HR diagram. And you can see, for example, here, right, it gives you an idea of where is the main sequence on the HR diagram, where is a giant or red giant. You could clump the giant, super giant, red giant together in one class and now, and where's the white dwarf right there, right? So looking at this HR diagram, just go back to your cluster and just identify as best as you can which member of these cluster A are main sequence, which member of these are the white dwarf, and which member of these are the giant. Okay. So those are the 3 questions you need to answer. And 1 second. And then, of course, right, to answer the first 5 questions from part A right here using the lab manual. We did this lab already. I just want to review, have us review this again one more time. Okay. And finally, right, if you cannot do it using Colab, you can do it by hand and turning this in right here. You see that these are the lab that I'm not going to tell you how long that was right there, right? But it's like a ton of the last century right there, right? So these, we did it by hand before, right? But just that technology has improved and it changed so much that we're able to do it on Colab nowadays. So, and make sure you turn it in, because if you don't turn it in, that I cannot give you partial credit. Okay, so give me 1 second. Let me stop the recording right